So this video is going to cover how to solve right triangles. We're going to be using our SOHCAHTOA to solve the triangles. So remember, sine is opposite side over hypotenuse, cosine is adjacent side over hypotenuse, and then tangent will be opposite side over the adjacent side. When the instructions say to solve the right triangle, once we're done, you will be able to have found all three angle measures and all three side lengths. Just like with the calculator portion of the 5-3 homework, your calculator must be in degrees. So you would always, if you've cleared the memory, you need to hit that mode button and then put it back into degrees. One way to confirm that you are in degrees is you will hit the tangent button, 45, hit enter, and again, you should be getting 1 as the answer. If you're getting 1.6 something, then you're still in radians, and fix your calculator. So let's try the first example. Now, you may be given a picture, you may not. It all depends on the problem. So here, what you need to do is if they tell you that the triangle is ABC and the right angle is at angle C, then you will put your right angle here at C. It won't matter where you put your A and your B. Now, what's going to be important, though, is where you label the sides. So the side across from angle A will be lowercase a. The side across from angle B will be lowercase b. And then the side across from angle C will be lowercase c. Now, once we're done solving this triangle, we will have found the measure of angle A, which actually they gave it to us. It's 31.67. We will find the measure of angle B, angle C, which I also already have. And then I'll also be able to have found side length A, which they gave me, 35.9 kilometers, side length B, and side length C. Now, if you remember back to your geometry days, you learned that the three angles of a triangle always add up to be 180 degrees. Now, you also learned a corollary that stated that the two acute angles of a right triangle are complementary. So if you have the right angle and one of the acute angles, the fastest way to find the other acute angle is just to do 90 minus the acute angle they gave you, and that'll give you angle B. Once I do this subtraction, 58.33. Now the instructions say to round to the tenths place, so 58.3 degrees. You could also add 90 plus 31.67 and then subtract that sum from 180, but the fastest way to find that other acute angle is just subtract the one they give you from 90 degrees. Now what we have to find are the side lengths, and this is where we use our SOHCAHTOA. So always, and this is important, try to use the given information. Don't try to use a calculated answer. Because let's say you did this subtraction, and let's say your finger slipped on the calculator. And let's say instead of 90 minus 31.67, you did 90 minus 32.67. Then your angle B would be wrong, and then if you use that number to find little b and little c, then those are going to be wrong too. So always try to use the original given to find all the pieces if possible. So what I'm going to do to find little b and little c, I'm going to label my sides, my opposite, adjacent, and hypotenuse, based off the given angle, which was A. So in relation to A, little a is the opposite to angle A, little b is adjacent, and little c is the hypotenuse. So far I know this, and I know this. I'm working with my given, and my given was this and this. So to find little b, which one of the SOHCAHTOAs uses opposite and adjacent? Tangent. So what we're going to do to find little b, we're going to do tangent of 31.67 is equal to opposite over adjacent, which I'm solving for. And now we're going to go ahead and solve for b. So whenever the variable ends up in the bottom of the fraction, we're dividing to solve. Because what we're going to do here is multiply both sides by b. You could also solve this as a proportion. I'll show you what I mean by that when I solve for c. That'll cancel b out of the bottom of the fraction. So now we have tangent of 31.67 times b is equal to 35.9. I'm trying to solve for b, so now I divide both sides by tangent of 31.67. Once you do this, rounded to the tenths place, little b, you're going to get 58.195, so 58.2 kilometers is the length of side b. So 58.2. Now we got to find the length of the hypotenuse. So now if I come up here, I got to figure I'm going to go back to my original. So I'm going to be using opposite again, the 31.67, and I'm trying to find the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So we're going to do sine 31.67 is equal to opposite over hypotenuse. And now, if you want to do this as a proportion, you could add a 1 underneath here and then just do the cross products. So you could solve it this way as well, because when you do that diagonal, you get sine 31.67 times c equals 35.9 times 1. And again, you're still just dividing both sides by sine 31.67. And then you get little c, or side length c, is equal to 68.377, rounded to the tenths place, 68.4. And that will be the length of your hypotenuse. Now, after you're done solving this, make sure that your answers are making sense. Remember, the hypotenuse, the side across from the 90 degrees, that answer should be the biggest number. If it's not, chances are you did something wrong. And then the smallest side should be across from the smallest angle. And then the medium size across from the medium. So like angle B was 58.3, and notice it was across from the 58.2. Now, because these are like both 50s and the A's are both 30s, that's just coincidental. The thing to check is make sure that A, B, and C, all three of those angles should add up to be 180. Now, you could do Pythagorean theorem to check your answers. I don't recommend that you do Pythagorean theorem to get a side length. I would use it to check it. Because again, some of these numbers are rounded answers. Okay, so same thing here. Now, if you're not given a picture of a triangle, you can label it yourself. So again, the lowercase letter a will be across from angle A, lowercase b across from angle B, and then C here as well. Now, whenever they give you one of the acute angles, to find the other one, angle A, all I have to do is 90 minus the 47.8, subtract that, I get 42.2, and that's going to give me the measure of angle A. That's usually the easiest thing to find. Now, I've got all three angle measures. So angle A, 42.2 degrees. Angle B was given to me, 47.8. And angle C was the right angle. Now I need to use my trig to find the missing side lengths. Now, they also gave me the hypotenuse. it was the 89.6 centimeters. Now remember, once you're done and you're finding side A and side B, if you're getting numbers greater than 89, then that's a clue you've done something wrong. Because remember, the side across from the biggest angle is always the biggest side. And that's my hypotenuse. So what I'm going to do is label my sides based off my given angle, angle B. Now, you could use angle A if you were confident in your subtraction. But I'm going to label them based off of B. So this is the hypotenuse. Always label that one first. It's across from the right angle. Then the side across from the angle that we're referencing. This will be the opposite side. And then lowercase a is going to be the adjacent side. So now if I want to find the adjacent side first, solve for A first. I'm going to go ahead and look to see what name did I give to side A. That's adjacent. And then I'm also going to use my original given. So I got to figure out of my TOA, which one uses A and H, adjacent and hypotenuse, and that's going to be cosine. So I'm going to be doing the cosine of 47.8 is equal to adjacent over hypotenuse. And now I need to solve for A. When the variable's in the numerator, all you're really doing is multiplying to solve. So I'm going to multiply both sides by the 89.6. It'll cancel it from there. So now you're going to multiply the cosine of 47.8 times that hypotenuse length, the 89.6, and we're going to round our answer to the tenths place. So once I do this, I get 60.186. It's going to keep going. So 60.2 centimeters is going to be the length of this adjacent side. So 60.2. And now I'm going to do sine to find little b. So for little b, I'm going to do sine of 47.8 is equal to opposite, which is b, over hypotenuse, which is 89.6. And when the variable's in the numerator, all you're doing is multiplying to solve. So sine of 47.8 times the 89.6, and then you get b is equal to 66.376, so 66.4 centimeters is going to be the length of the opposite, or little b. And when you go to do these, so let's say I put little a over here, that was the 60.2 centimeters. Little b was the 66.4 centimeters, and the hypotenuse was given to me. So if you look at these, they make sense because this is the smallest angle and it's across from the smallest side. This is the biggest angle, it's across from the biggest side. And then the medium size angle across from the middle size side. So once you do this, see if it makes sense. Now, technically you could do a squared plus b squared equals c squared, and it should be close. It'll probably be off a little bit because those are rounded to the tenths place answers. But that's a way that you can check. Also, if you add these three angles, they need to add up to be 180. If they don't, you've done something wrong. Okay, so I've labeled my triangle A, B, and C. I went ahead and found angle B by just subtracting the acute angle A that they gave me. 90 minus 61 was 29. So now, so far, I have angle A was given to me. I just found angle B, and they also gave me that angle C was the right angle, so it's 90. So now I need to work on finding lowercase a, lowercase b they gave me, and lowercase c, my hypotenuse. So I'm going to be using my given side here, my adjacent side, to find both a and c. So when I first work on finding the opposite side, I got to figure out which trig function is going to use opposite and adjacent. and that's going to be the TOA. So I'm going to be doing tangent of 61 is equal to opposite over adjacent. And again, when the variable is in the numerator, all we're doing is multiplying by that denominator to solve, because it cancels it from the right side. And now on your calculator, 39.2 times the tangent of 61 is going to give me A rounded to the tenths place, 70.7 centimeters. Now for the hypotenuse, I'm still using adjacent. So for hypotenuse, I'm going to be looking to see my hypotenuse and my adjacent. And that's going to be my cosine. So cosine of 61 is equal to adjacent over hypotenuse. This time my variable's in the bottom. So essentially in the end, we're going to be dividing to solve. So what we're going to do is multiply both sides by c to get rid of the fraction. So now I have cosine of 61 times c equals 39.2. Divide both sides by cosine 61. And little c rounded to the tenths place, 80.9 centimeters. And again, it's making sense. The hypotenuse should be the biggest. And the 70.7 was across from the medium size angle, and the 30.9, the given, was across from the smallest angle. So it makes sense. Okay, so for number 4, here's my triangle. C has to be the right angle. I'll put B up here at the top again. And again, little b is across from angle B, little a across from angle A, little c here. They gave me angle B this time, and it's 46 degrees. And they gave me the hypotenuse, 29.7. Again, I'm going to label my sides with opposite, hypotenuse, and adjacent based off the 46, the given acute angle. So now, little b in relation to that angle is opposite, c is the hypotenuse, and little a is the adjacent. Again, the easiest thing to find first is that missing angle. Do 90 minus 46, and that's going to give us 44 as the missing angle, angle A. So it's 44. Okay, so now that I've labeled the sides, again, use your given. So I'm going to use the hypotenuse, and I'm using this angle. So now when I want to find little a, I got to figure out which one from my SOHCAHTOA is going to use adjacent and hypotenuse. And again, it's going to be cosine. So I'm going to do cosine of 46 is equal to adjacent over hypotenuse. I'm going to go ahead and multiply both sides by 29.7. It'll cancel that. So on your calculator, little a is going to be rounded to the tenths place, 20.6. And now, to find the opposite side, I'm still using the given, the hypotenuse, so I got to figure out which one's going to use opposite and hypotenuse, and that's going to be sine. So sine of 46 is equal to opposite, which was little b, over 29.7. Variables in the top, so just multiply 29.7 to both sides. Sine of 46 times 29.7, rounded to the tenths place, 21.4. And again, these were meters. So we found angle A was 44. Side length A was 20.6. That was little a, meters. Angle B was given, 46. lowercase b, or opposite, we just found it, 21.4. Angle C was the right angle, and the hypotenuse was given to me from the beginning. And again, the hypotenuse is the biggest number. Makes sense. And again, smallest angle has the smallest side. They're all pretty close, but again, it makes sense. Now we're going to do the scenario where they give us two sides. And we're going to do the inverse. So we're going to hit the second key to find an angle measure. All right, so for this one, again, they're telling us C is the right angle. So C will be here. I could put B up here at the top again, and then A. They're giving me little b, 489 meters. They're giving me little a, 958 meters, and I don't know C. Now, in order to find the hypotenuse, we're going to do Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. They gave me a, 958. I'm going to square that. Square the b, 489. I have to square first, then add. So this gives me 917764 plus 239121 equals c squared. Add them. And then I got to square root it. Round it to the tens place. I'm going to get 1075.59, but I'm going to round it to the tens place, so 1075.6. And these were meters. So that's your hypotenuse. Now, to find the angle measure, I'm using the original sides. So I'm going to find angle A first. So I'm going to label my sides based on the angle I want to solve for first. You could do B as well. It doesn't matter. So C is the hypotenuse. Little b is adjacent to A, and little a is opposite to A. I need to figure out which trig ratio uses opposite and adjacent. And that's going to be my... You can do B. It doesn't matter. I'm going to solve for A first. I'm just doing it alphabetically. If you want to do B first, then you would label the sides based off of B. All right, I heard somebody say tan. So we're going to do tangent, but we're doing inverse because we're looking for the angle. So I'm going to be doing tangent -1. Remember, to get that, you hit second and then the tangent button. And then in here, I'm going to fill out opposite over adjacent. So tangent -1. My opposite side was the 958. And the adjacent side is the 489. And then you're going to hit enter. And you're going to round to the nearest, let's do the nearest degree on this. So the nearest degree, angle A, is going to be 63 degrees. But the easiest way to find angle B is just do 90 minus 63. So angle B is going to be 27 degrees. So just read what it tells you to round to. Okay, so that completed my triangle. I now have all three angle measures. Angle B, angle A. Angle C was the right angle from the beginning. And then I found the missing side, and they had given me the first two. So let me draw my triangle. So ABC again. C still the right angle. This time they're giving me little a, 26.5 centimeters. They gave me the hypotenuse this time, 39.7 centimeters. I don't know little b. So again, to find the missing side, when you know two of them, you do Pythagorean theorem. So again, a squared plus b squared equals c squared. So 26.5 squared, I don't know b, and then 39.7 squared. So I'm going to square these. This gives me 702.25 plus b squared equals 1,576.09. I have to subtract to solve this time, not add. And then I get b squared is equal to 873.84. Square root both sides, because I don't want b squared, I want b. Round that to the 10th place, 29.6 centimeters. So that's the missing side that I didn't have. Now I got to work on the two acute angles. And again, to find an angle measure, we do inverse. So this time, notice, let's label the sides based off of A again, but you could do B. But based off of A, this side is the hypotenuse. This is adjacent to A, and little a is opposite. So I got to figure out which one of the trig functions uses opposite and hypotenuse. Those are the two sides that they gave me, and that's going to be sine. So you're going to do second sine, so it opens up sine to the -1, and then put in opposite over hypotenuse. Hit enter. And once we do this, you should be getting rounded to the nearest degree. Angle A is 42 degrees. And then to find angle B, we're going to do 90 minus 42, and angle B will be 48. If you would have rather done cosine, we could also, to get angle B, do cosine -1, 265 over 39.7, and that would give us the answer as well. But honestly, you can do it either way.